All right, so here we are. We're talking about critical points today. So, what is a critical point? This is one of my favorite things in calculus to teach because it took me a long time to figure this out in the 4 times that I took calculus in college. So, for a continuous function, so a function that has a point everywhere, I can drive a car through every single point on this graph. For a continuous function f of x, we can find the x values of critical points when f prime of x is equal to 0. In other words, I drew a gray graph just in the shape of a W because that's what came to mind, where it's not a parabola, it's not a line, but you could have multiple low points or high points. In other words, the slope of the tangent line is horizontal at these points. See this? Low point, high point, low point. The slope is 0 at these points. So if you have a function and you set the derivative equal to 0, the x values when f prime of x is equal to 0 will give you these critical points. Okay? That's what's going to be the main focus of this unit's test. So the other part is, well, what happens when f prime of x does not exist? So I might answer this towards the end of May, but for now, I want you to understand that a critical point occurs when f prime of x is equal to 0. When I was in college, they taught this as f prime of x is not differentiable. In other words, somebody raised his hand in my calculus class one time and said, well, what does it mean when f prime of x is not differentiable? You can't take the derivative at that point. No, I got that. What does it mean when f prime of x is not differentiable? You can't take the derivative. No, I got that. And so we just said, never mind. Let's just get through this. And so I was classmates with him for Calc 1, Calc 2, and Calc 3. Same question, but nobody could explain it. But then in Calc 3, one of my favorite professors was teaching, when f prime of x is not differentiable, and he's soon enough, what does it mean when f prime of x is not differentiable? F prime of x is differentiable when it's a smooth curve. So f prime of x is differentiable if it's a smooth curve, if it has an elbow or a hard corner. Sharp corners are not differentiable, my friend. So I always associate that really good professor with defining for me, what does it mean when f prime of x does not exist? So at this sharp corner, I just picked an absolute value. That's when a critical point occurs when f prime of x does not exist. But for now, I just want to clarify, the main focus of this class is going to be when f prime of x is equal to 0. Okay? So a critical point is a point where the slope of the tangent line is either horizontal or undefined. The long-term goal of this, do we have a local minima or a local maxima? So the goal is to figure out, do we have local minima or local maxima? And that'll be defined in the next video. But for now, let's do these problems. Let me just get problem number 1 right up there. Where are you, number 1? Okay, so the directions say find all the critical points. So, for instance, in the graph, f of x is equal to x cubed minus 3x squared. We want to figure out where are the critical points. So step 1, set f prime of x equal to 0. So I've got f prime of x. I'm going to take the derivative with respect to x. The derivative of x cubed with respect to x is 3x squared. And the derivative of negative 3x squared is negative 6x. Okay? So now we have f prime of x. We're going to set it equal to 0. And then we're going to solve for x. So once you've figured out the x values for 3x squared minus 6x is equal to 0, go back to Algebra 1, go back to Algebra 2. It's all coming back now. So what do we do to solve for x? Well, I can factor the GCF 3x. Factoring never goes away. You laugh, but you see now why I drilled you guys on factor. Okay, so 3x is the GCF of 3x squared and negative 6x. 3x times what is 3x squared? Well, 3 times 1 is 3. X times x is x squared. So 3x times x is 3x squared. 3x times what is negative 6x? Negative 2. Go back to Algebra 1 now. Now we can do the zero product principle to split these two into two separate equations. Either 3x is equal to 0 or x minus 2 is equal to 0. So let's just get this over with. 3x is equal to 0. Well, divide both sides by 3 and you know the routine. X is equal to 0. That's one of the critical points. Sorry, one of the x coordinates of the critical points. X minus 2 is equal to 0. So we add 2 on both sides. X is equal to 2. So therefore, the x values for the critical points are at x equals 0 and x equals 2. Now, step 2 is find the y values of the critical points. So now that we've established that x equals 0 and x equals 2 are the places where this curve has horizontal tangent lines, let's plug x equals 0 into f of x and x equals 2 into f of x. So I'm going to do f of 0. How exciting. X cubed minus 3x squared. So let's plug in x equals 0. Well, this is very, very exciting. 0 cubed minus 3 times 0 squared. Well, that's just 0, which means that one of the critical points is at x equals 0, y equals 0. Okay. And now let's figure out f of 2. Well, that means I'm going to plug in x equals 2 into x cubed minus 3x squared. Okay, so 2 cubed is 8. We have to do 2 squared first, so that's minus 3 times 2 squared, that's 4. So that'd be 8 minus 12, or negative 4. So therefore, my critical points occur at 2, negative 4, and 0, 0. And I can check my work with Desmos. So I'm going to pull that up right now. Come on, it's this graph. Okay, so here's the graph for x cubed minus 3x squared. This is a high point, 0, 0, and this is a low point, 2, negative 4. Now, I know what you're probably thinking, wait a minute. Is there a way to figure out which one is the high point and which one is the low, which one is a high point, which one is a low point? Yes, in the next video, I will show you those two methods to do that. Okay, let's move on to problem number 2. F of x is equal to 2x cubed plus 3x squared minus 12x. Let's find all critical points. So let's follow the same old steps. In other words, I need to find f prime of x. So let's take the derivative of 2x cubed. That would be, by power rule, 6x squared. And the derivative of 3x squared would be positive 6x. And the derivative of negative 12x, that would be negative 12. So step 1, set f prime of x is equal to 0. I want to figure out where do I get horizontal tangent lines. Step 2, we got to factor. We got to factor and see the x values. So first things first, what can I do? Well, 6, 6, and 12, I can factor out the 6. 6 times what is 6x squared? That would be x squared. 6 times what is positive 6x? You can put a positive 1x or a positive x, your call. 6 times what is negative 12? That would be negative 2. is equal to 0. So that 6 gets factored out. And, oh, you didn't tell me that factoring was going to be part of... Yes, I did. I told you a million times. Factoring is going to be a part of calculus. Factoring does not go away. We need to factor x squared plus x minus 2. You know the drill. We got to figure out the winning team. What multiplies to negative 2 and adds to positive 1? What multiplies to C and adds to B? So, anybody know? How do we figure this out? It needs to be a positive-negative combination with a stronger positive. So what comes to mind is negative 1 and positive 2. Negative 1 times 2 is negative 2. Negative 1 plus 2 is positive 1. The reason why is because 1 and negative 2 would multiply to negative 2 and add a negative 1. So this is the combination that we want. Yippee. So therefore, we factor x squared plus x minus 2 into x minus 1, x plus 2. And now, we can use the zero product principle to solve for x. So either x minus 1 is equal to 0, or x plus 2 is equal to 0. So let's solve. So now, let's split them up and solve for x. Subtract 2 from both sides on the right equation. One of the critical points is x equals negative 2. That's the x value. We'll find the y value soon enough. Okay, add 1 to both sides. On the other equation, x is equal to positive 1. So the x values of the critical points are at x equals 1 and x equals negative 2. Those are the horizontal tangent lines. All right. Now we need to figure out where the y coordinates are. So now we look at f of x, 2x cubed plus 3x squared. Oh, sorry, 2x cubed rather. So if I plug in x equals 1, well, that's just the exciting 1 cubed, which is 1. 2 times 1 cubed is 2. 3 times 1 squared is, that's going to be 3 times 1, so that's 3. And then negative 12 times 1 is negative 12. So 2 plus 3 is 5, minus 12 would be negative 7. Therefore, there's a critical point at x equals 1, y equals negative 7. And let's plug in for the other part. F of x is equal to 2x cubed plus 3x squared minus 12x with x equal to negative 2. Okay, let me just put the focus back. There we go. Good job, camera. So now we're going to plug in and do PEMDAS. Negative 2 quantity cubed, that would be negative 8. Negative 2 quantity squared, that's positive 4. No PEMDAS, no exponents here, so that's just negative 12 times negative 2, which would be positive 24. Now, 2 times negative 8 is negative 16. 3 times 4 is positive 12, and plus 24. Negative 16 plus 12, that would be negative 4. And negative 4 plus 24 would be positive 20. Therefore, when x is equal to negative 2, y is equal to positive 20. So our other critical point is at negative 2 comma positive 20. Let me check with the graph. So now that we're going to get this graph up here, let me go back to home. Ooh, the graph is purple. I like purple. Okay, so I'm going to zoom out. Notice that I care about that high point and that low point. Notice I didn't say highest because the graph goes all the way up to positive infinity. And notice I didn't say lowest because that graph goes down to negative infinity as well. I care about where is the tangent line horizontal. So where is it? negative 2 comma 20, and 1 comma negative 7. In the next video, we'll show how do you know that negative x equals negative 2 is a local maxima, and how do you know that x equals 1 is a local minima. Okay, moving on to problem number 3. Okay, f of x is equal to x to the fourth minus 2x squared. Okay, well, how do we do this? Well, I want to figure out where the local minima and the local maxima are. So first things first, we want to figure out where the horizontal line is equal to 0. Let's take the derivative, set it equal to 0. What's the derivative of x to the fourth? 4x cubed. What's the derivative of negative 2x squared? Negative 4x. Set the derivative equal to 0 because we care about where is that tangent horizontal. Where's that tangent line going to be horizontal? Now we got to solve for x. Okay, so my good buddy factoring. What can I factor out of 4x cubed and negative 4x? I'm going to factor out a 4x. 4x times what is 4x cubed? Well, 4 times 1 would be 4. X times what would be x cubed? X squared. Aha. Now, 4x times what is negative 4x? Negative 1. So now we've got 4x times x squared minus 1 is equal to 0. Go back to algebra 1, go back to algebra 2. This is all it is. Because now we've got to factor x squared minus 1. It's the difference of two squares. Everybody straighten the tie. We're going to factor it into conjugates. So x squared minus 1 is the difference of two squares. The square root of x squared is x. The square root of 1 is 1. So we can factor these into conjugates, specifically, leave that 4x alone. This is x plus 1, x minus 1 is equal to 0. Look at that. We've got 3 critical points we can play with. So solve for x, and we'll get 4x equals 0, x plus 1 equals 0, x minus 1 equals 0. Okay. I'm just showing my work. All right, so let's start off with the easy one. 4x is equal to 0. Let's just divide both sides by 4. What could possibly go wrong? X is equal to 0 divided by 4, or x is equal to 0. X plus 1 is equal to 0. Let's subtract 1 from both sides. And x is equal to negative 1. That's another x value where the slope is horizontal. X minus 1 equals 0, so we're going to add 1 on both sides. And so x is equal to positive 1. 3 critical points. Now, we need to figure out where those y coordinates are for these critical points. So the original f of x is x to the fourth minus 2x squared. All right? So if I plug in x equals 0, 0 to the fourth is 0, minus 2 times 0 squared. I don't need to write this whole thing out. I know it's going to be 0. So therefore, at x equals 0, y is equal to 0. That is a critical point. All right, now let's plug in x equals negative 1, x to the fourth minus 2 times negative 1. So now that I'm plugging in x is equal to negative 1, negative 1 quantity to the fourth power, that's negative 1 times negative 1 times negative 1 times negative 1. There's 4 negatives, that makes a positive, and 1 multiplied by itself doesn't really matter, it's just going to be 1. Negative 2 times negative 1, that'd be positive 2. And then 1 plus 2 is 3. Therefore, when x is equal to negative 1, y is equal to positive 3. That is my critical point. One last critical point is f of 1 is equal to, f of x is equal to x squared minus 2x. So now, if I plug in 1, sorry, wait a minute, hold on. Squared. Oh, hang on. That's supposed to be a square. I apologize. 1. Let me put this on the side over here. That is 1 minus 2 times positive 1. There we go. And then 1 minus 2, that'd be negative 1. So my critical point is, in fact, at negative 1 comma negative 1. Oh, boy. Negative 1, negative 1. And then finally, yeah, let's get this right. See, even I need to look at this because I always make sure I look at the graph and go, hey, wait a minute, that's not right. You need the multi-sensory learning when it comes to calculus. Because one small slip up and, you know, it's a domino effect. So 1 to the 4th is 1 minus 2 times 1 squared, that's 1. And yet again, 1 minus 2 is negative 1. So not only is x equals negative 1, y equals negative 1, we get x equals 1 and y equals negative 1. So the point of the matter is 3 critical points. 0, 0, negative 1, negative 1, and 1, negative 1. Let's confirm with that graph. Look at this. So it's in the shape of a W. Look at that. That's an x to the 4th graph right there. Negative 1 is a low point. 0, 0 is a local maxima. And 1, negative 1 is a local minima. So 2 local minimas and 1 local maxima. Okay, in the next video, we're going to look at these 3 problems and we're going to explore how do we know without graphing that these are the local minima and local maxima. Have a good day.